Hi there, I'm playing with some junk again, and this time it is very antique junk. Well, if you look at it, you may not immediately see what it is, but it's a radio. And even if there is a control label from 1933, this radio is a little bit older. It's from 1926. And the model is a SABA HANN 26 or 27. Well, 27. Or it's also called HANN 1800. And yeah, it's the oldest radio in my collection. Here on the top you can see a glass window, and the top cover can also be opened, which is necessary to adjust the coils here, although this has only been must be done for one time and then you leave it alone. Yeah, we will have a look inside because there is quite an interesting circuit here. Okay, let's see what it does. I already removed some screws, and then the whole chassis hopefully pops out here on the front. Yes, now it comes. Have to be careful with these coils, they're a little bit too high here. Okay, that's it. Maybe you have already noticed that the second low frequency amplifier tube is a completely different model than this one, but it should be the same. The reason is, well, I don't know, someone has altered the circuit. This has absolutely no function. It's a rectifier valve or tube, and it has nothing to do in this circuit, and even the socket is not completely wired, so someone decided to get rid of the speaker amplifier. There is also a transformer missing here, about in this space here, and they only hooked up the heater, so to make this lamp here glow or not, even if it has not much sense because it's completely black. I don't know if that one is broken. I ordered a new or new old tube from eBay. This is the same as this one, so I can replace that one, and then at least it looks like original. I still don't have the transformer, but I don't need that because I don't want this radio to work, because it has a few special tricks on its sleeves. For example, there is no power supply. The power supply for this radio is originally batteries. And here is an image from the original user manual. You can see you need two batteries. The big one with the handle is the heater battery. This is normally a rechargeable battery, and the other one, like this one, is a battery that has to be replaced when it's empty, but they say it's good for about a month or so. And this is the schematic diagram. You can see we have the four tubes here, these round things, and we have the antenna on the left side with ground. That's two wires that have to be connected. Then the first transformer, these adjustable coils, the green ones. Then the second tube from the left is the Odeon, the demodulator. And then from there on, there comes the first low frequency stage for the headphones and the second low frequency stage for the loudspeaker. And you can also see on the bottom right we have 120 volts, 50 volts, heater is 4 volts, and we have a couple of ground connectors. That's what you connect to the batteries. And here you can see this battery connector. It has 1, 2, 3, 4, 5, 6 pins. It's called the Orion connector. That's a word invented by SABA. And yeah, it has 120 volt for the anodes of the first and third and fourth tube. It has 50 volt for the second tube anode. It has 4 volts for all the heaters. They are working on 4 volts here. And we have at least 2 ground pins that are connected together. Okay, let's talk about the many dials and knobs on the front panel. The first one is down here. That's the power on and off switch. And that only powers on or off the heater of the tubes. And all the other voltages are still connected, going to the tubes, but it makes sense because if the heater is not working, these tubes are basically complete isolators, so whatever voltage you apply to them, there is no current going through unless you heat the cathode up and then current starts to flow. So the only voltage you have to turn on or off is the heater, and everything else can be connected. So that's what they did. Then we have the first capacitor here. That's the first big knob on the front panel. That's together with this coil here is the antenna resonator, or the oscillating circuit, however you want to call that. Then we go to the first high frequency tube, go out to this transformer osci here. That's a second resonator or oscillator circuit that is connected to this variable capacitor. And this one even has a fine tuning knob, which is at the moment a little bit broken, so the screw here is missing, and I also had to fix the knob here. It was broken completely. There is a gear here. Maybe you can see that. So there is a gear reduction. Let me see if I can turn it. Yes. So the shaft goes through to this silver box here. There are 2 more gears, reduction gears. Then we have the small gear here. You can see that behind this wire, and that drives the large gear, which is connected to the capacitor. So that's fine tuning. Then we have this knob here that turns this coil here. And by the way, these coils are very beautiful. They are spun around some, I don't know, some poles, and they have this zigzag wavy wiring here. And the reason for that is to minimize capacitance from one wire to the next. So they spun it around this guiding mechanism to separate the wires as much as possible. So they call it a low loss inductor. And the part I'm turning here is an inductor that provides feedback to the high frequency tube. And that increases the sensitivity of the primary circuit here. So you feed some of the output of the tube back to the input, and that increases the signal amplification. The problem is if it's parallel, so you have a maximum feedback. If it's perpendicular to each other, you have a minimum feedback. If you turn that too high, you turn the entire stage here into an oscillator, and that does not only prevent you from hearing any radio station, it will also prevent any of your neighbors from hearing any station, because you turn your radio into a transmitter with a weird beeping sound, and that's not very useful. So you have to be careful not to turn that into the wrong position, or you will probably kill all the stations for your neighbors. Okay, and of course your neighbors have to be careful too with their receivers. Then the last two dials here are the potentiometers for the heaters. So that's the heater regulator. And there are 4 potentiometers for each tube 1. And if you look closely, that's the potentiometer, and you can see they are rotating the resistor part, and the wiper, which normally rotates in modern potentiometers, stays stationary. So that's the other one. So that's the position with the insulating pad, so that's heating off, and then we go around until we have full power on the heater. The manual for this machine says you shouldn't apply full power to any tube. I'm not sure why. Maybe, well, they certainly live longer with less heating, and probably you get problems with this feedback circuit if the tubes are too good to or amplifying too much. I don't know. You may have noticed when I explained all these knobs and buttons, there is no volume regulator, no volume potentiometer. Well, that's true, yes. This radio doesn't have a volume regulator. You have 2 output sockets here. One is meant for headphones and one is meant for a speaker. And depending on how loud you want to listen, so this is the more silent one, this is the louder one, you can put your headphones to the speaker output, so you have more volume, or you can put it to the headphone outputs, or you could also connect your speaker to the headphone jack, and you have a very silent radio. And of course you could regulate the heaters for the audio amplifier, so although that's not really recommended, but you could do that and decrease the listening volume like that. And otherwise you could probably detune the station a little bit, so if it's too loud, well, you have plenty of options to do so, but there is no volume regulator. Other than tubes and potentiometers and dials and stuff, we have very few other components. For example, this one is one capacitor of 2. We have 2 capacitors, that's it. And this one has can see it here. .001 microfarad. Or is it millifarad? No, I think it's microfarad. That's 1 nanofarad. Okay, so a 1 nanofarad capacitor. The capacitor is not attached to anything except to the very stiff cable, so it hangs here. And well, you could screw it down probably, but nobody has ever done that, so it's fine. Then we have another capacitor here, that's the second one, and we have one resistor here. And if you look at that closely, it has a socket that is similar to a fuse holder, but it also has these screw terminals here. Let me get a better screwdriver. They are screwed here into this holder, but there is also a hole for a wire, so you could put 2 wires into that resistor and screw them tight, and they are connected. It has 3 mega ohm, so 3 mega ohms. Yeah, and that's the third component, and that's it. The rest are tubes, and well, here a black transformer marked with Phillips. It's the only part that is not SABA. And here is a better view of this second variable capacitor with this reduction gear here. And the cover of the gearbox says this is a SABA Potentiometer. I don't know why they called it Potentiometer. It's a variable capacitor, but however. And the label also says here, made in Baden. SABA is a company located in the Black Forest in Germany, in southern Germany. And they are in the Bundesland of Baden. So they were very proud of that, and they didn't write made in Germany, they wrote made in Baden. Okay, why not? Nice touch. Well, I like the appearance of these coils here, especially with this mechanism. There is a hinge here. You can adjust the second coil well, it's an adjustable transformer. You have one coil, you have another coil, you have air as the medium between, and you can adjust how much of the signal gets from one coil to the other. And of course the same here. So the manual says when you start you should take these coils apart as much as possible, or as much as your space inside the receiver allows you to do that. I don't know why exactly, but well, they say that's a good start. And then probably if you have a weak station or so, you tune that a little bit closer, and then if you have your favorite station received, you close the lid and yeah, you leave it alone. Beautiful. And there's another shot of one of these coils, just to show you how nice they actually are. And I also love the green color here. It's a fabric insulated wire, so there is spun some, I don't know, silk or cotton around, and then dipped it into some sort of lacquer, and everything is secured with, come on, focus here, thanks, secured with these threads here. Yeah, quite nice. By the way, you could buy this receiver, this radio, as a complete machine, or it was also intended to build it yourself, so you could buy all these parts here independently and build your own radio receiver. By the way, in 1926 or 27, this radio cost about 300 Reichsmark, which is today about 2,000 euros, or American dollars, or Swiss francs. You can choose, it's almost the same at the moment. Yes, and that was without all the tubes, so the tubes were extra. I don't know how much they cost, but they were probably the most expensive parts. So we are talking about a very expensive device. By the way, I don't know if I already told it, I bought it on a flea market and I paid $5. 5 Swiss bucks, Euro bucks, US bucks. Choose it as you wish. It's 5, and that's very, very cheap. And as you can see, everything is mounted, screwed to this main board. Yeah, that's the main board, made of wood, a piece of wood, that's a board. And an interesting detail are those connectors here that connect one wire with another. It's some sort of screw terminal. I have never seen that before. But here in this radio we have quite a couple of them. So I don't know if the guy who made this was bad in soldering, but on the other hand there are solder joints. Maybe this wire was already attached and then you had to screw it together with this line here. By the way, that's the heater voltage here, goes to this F part. F means filament, or that's the heater. And on the other side we have also an F here, that's the other pole of the heater. Then we have I think, yes, that's with the rubber sleeve, that's the anode, that's the high voltage positive. And on the other side of the tube, the fourth connector is G, the gate or the gitter. So that's the electrode that steers the whole thing. And another funny detail is this power switch down here. Let me go a little bit closer. It looks like a headphone jack from far. Let me bend that away a little bit. But you see there is a plastic part that rotates and it expands the two leaf springs there. And if they go out, they make contact with the second spring here, and that closes the circuit. So this is the off position, this is the on position. We have two switches, one is here, the other one is down here. It's the same principle, and they are switching plus and minus pole of the heater. So we have plus 4 volt here, we have the ground here, so it's disconnecting the heater completely. And that's the whole on and off switch. And did you know that this 1/4-inch jack plug here is probably the oldest plug that we are still using today, the headphone jack. This comes from telephone exchanges. If you look at old pictures of telephone exchanges with the many girls with the many cables with jacks like this one, they're using exactly this type of jack to connect you to your telephone receiver or to the other person on the line. 1/4-inch, 6.3 millimeters, mono headphone jack, more than 100 years old and still in use, unchanged. So that's a relatively new connector. Fits perfectly in my antique radio, as you can see here. Makes contact and the groove is exactly where it should be. Wonderful.